Good evening, good evening, good evening. Okay, let us start with the second problem today. I'm a bit late today, but anyway. Okay, the question is, what is the work done by a particle of mass 1 kg when it moves along an incline and the angle of incline is given? Anyway, substitution of parameters, we'll do it later on. But let us begin with the problem. So we'll do it by multiple methods as the video itself suggested. We are not going only to do with only one method. Let us learn all the one or two methods. So first method, let us first draw the incline. Incline looks like this. This is my incline. And then you take a mass. This is my angle theta. Anyway, the value of theta is given to you. Value of theta is given to you. And the mass of this object is m here. This is also given. M is given. So what I will do is, let us consider that this height is h. Okay, this height is h. And the length of this incline is L. Length of this incline is L. So therefore, let the vertex here be called as O. I'll label this as A, and this is B. Okay. Now let us begin the problem. Now we need to find out the work done by a particle of mass 1 kg. So what is the work done by gravity here? So now the object slides like this because the gravity pulls it like this. We need to find out what is the work done towards it. Now what do? We need to find what is the force acting on this block at this point. Let me start with the first method. First method is by making use of the mechanics problems. Okay, why mechanics? The reason is because gravity is present here, which is a constant force, and as a result of this mg can be resolved into two parts. Can be split up into two parts. Those who have learned about the resolution of vectors, you will understand this. So if this is mg, this is theta, then definitely this angle is 90 minus theta. I'll draw it separately if you want. Hey, this logo anyway, I put this in the middle. Okay, so that to authenticate that this is my video. Okay, so now this is my mg vector. Then this is my inclined plane vector, and this is my angle theta. If this is angle theta, if I complete this, you will get this as a right angle triangle here. Okay, I'll just draw it by a dotted line. If this is 90 degrees, then this angle is theta, then this angle should be 90 minus theta. This angle should be 90 minus theta. Okay, the object is kept here. The mass of the object is being pointing downwards like this. Now, if I draw the free body diagram, then the normal force will be perpendicular to this surface. This will be my normal force. Okay, now what I will do is, I will consider the contribution of mg, that is resolve this vector, into two parts. One opposite to this normal vector, like this. The other one along the plane. Okay, why should I do it? What is the need for it? The need for it is you need to arrive at an FBD, free body diagram. And finally, you also need to resolve the forces. It should be only along x and y axis. So by conventional method, we are not going to take the x and y axis like this. We are not going to take x axis here and y axis here. That's the way how we used to do it. Now, since the object is here, I have a freedom to choose whichever I want. So therefore, I am choosing, okay, this axis is my x axis. This axis is my x axis. And this axis is my y axis. Okay, vertically upwards. And this axis is my x axis. So if this is mg, then this is if this angle is 90 minus theta, this angle is 90 minus theta, this angle will be theta. Why theta? Because you see, this line is perpendicular to this plane. So therefore, theta plus 90 minus theta would be equal to 90. So that's right. Okay. So as a result of this, now this is theta. Now by resolution of vectors, we know that this side, it will be mg cos theta. Mg cos theta. And this side, it will be mg cos of 90 minus theta. Now, how do I get it? Simple rule. Okay, take this mg, call these two vectors as two neighbors. Okay, this neighbor says, okay, I want the value of mg. So you give the value of mg to this and say your contribution is mg times cos of the angle between you and me. Okay, what is the angle? Theta here. So mg cos theta. And this fellow will also ask, what is the contribution for me? Then you say, okay, your contribution is mg cos of whatever rule we applied here. Only thing is here, it is not theta, here it is 90 minus theta. We take this value. So you get this. Okay. Now we have resolved the one force into two parts. Okay. Now what we have is, this is the force. This force is equal to mg sine theta, mg sine theta. So thus we have a force which is pulling it like this. Is there an opposite force? There's no opposite force. Since there's no opposite force, this becomes an unbalanced force. As a result of it, the object starts sliding down the incline. Okay. Now here you see there's a normal force here. There's an mg cos theta here. See, normal force here and mg cos theta here. These two balance each other. As a result of it, the body does not fall down vertically downwards like this, or it doesn't go like this over here. Okay. Let me write down the force equations. N equal to mg cos theta here. Okay. So therefore, these two are balancing each other. So nothing happens in this direction. But while in this direction, we don't have any unbalanced forces on the opposite direction. That's the reason why the object is sliding. So I will write MA, the net force acting on it, is equal to mg sine theta. Where did I get sine theta? I took cos of 90 minus theta, which is sine theta. Okay. If you have learned trigonometry, this becomes quite easier for you to understand. Okay. And now, just a moment. So now we have resolved the forces. Here n equal to mg cos theta, ma equal to mg sin theta. So this mg sin theta is the force responsible for the object so that the gravity is now pulling it downwards like this. Now if I ask you what is the work done? Okay, what is the question? The work done by the particle. So simple, work done is equal to force acting in this direction multiplied by length, right? That is dot length. Okay, let us take dot length. So force multiplied in this direction is, what is the force acting here? mg sin theta is the force acting. Dot, what is the L here? Length here. Displacement. Displacement is length over here. So I get this. In other words, I can now write this as mgl sin theta. So first method, I'm able to get this. Now we know from this triangle OAB, we have h by L is equal to sin theta. Am I right? H by L is equal to sin theta, or h should be equal to L sin theta. Okay. From the trigonometry, see, from the triangle, I have got this one here. So what will I do now? I will take this value, see, L sin theta, I will substitute here, and thus I will get the answer as mgh. Got it? Work done is equal to mgh. Now, this is my first method. Many of you would have done this problem in your classrooms. Yeah, this is nothing great. What is this? Okay, we have learned all this earlier also. Good. If you have learned it, it's well and fine. Okay, but I want to show it to you. Okay, like how can we do by the other methods? Excuse me. Just a moment. Okay, so we have the first method. We already done the first method. Now let us look at the second method. Second method. What is the second method? So we have done the mechanics part. The second method is about making use of work energy. Work energy theorem. Now, what does work energy theorem tell you? Work energy theorem tells us that the work done by a particle, okay, if a constant force is applied, remember this term, if a constant force is, if a force is applied on it, is given by the difference in the kinetic energies. Difference in the kinetic energy. So I can now write this as half m into v final square minus half m into v initial square. Okay. So towards it. Now what do I get here? Half m into, what is v final? That means the object is being dropped from here. It keeps on moving like this. When it reaches here, it acquires some velocity. This is your final velocity, which should be vf square. Vf square minus, what is half m vi square? Vi square, there's no vi square at all. That is, vi becomes 0 here because it started from rest. So this is 0 over here. So thus this became half m v square. Okay. Work done, I'm getting it as half mv square. Yeah, then where is this mgh? I'm getting some other expression here, some other expression here, right? Now we need to use equations of motion. Okay. Now you see there's a constant force being acted here. When there is a constant force acted over here, so you know this is v here, okay, and this is u over here. So you can say that the acceleration is also constant, and hence you can do by two methods here. The first method I will do it by first method. We pull this. Okay. The first method I will do it by using equations of motion because you are conversant with. Okay. So therefore, what I will do is I will say that v square is equal to u square plus 2as. I'll use this method. Now u square is 0 plus 2 into, what is A? A here is nothing but G sine theta. See, I already got the force here. Where did I get? I get MA equal to G sine theta. Our acceleration along the plane is nothing but G sine theta, right? G sine theta, G sine theta, multiplied by S. What is S? S is a displacement here, L, right? L. And we also know that H equal to L sine theta. So now what I will do is I will simplify this. 2G into L sine theta. And for L sine theta, I'll substitute this value of H. So I get this as 2GH once again. Okay. So I will take this 2GH. What is this now? V square. V square. I'll take up this value and I will substitute it here, which will be half M into 2GH. So what do I get here? This 2 and this 2 cancels away. This should now be equal to MGH. Voila. See, I have got it once again, right? So work done is equal to MGH using the work energy theorem. We have got it with the second method also. Okay. Now I told you there are two more methods, one more method here. Okay, from here I told you two methods. So the first method employed the kinetic equations, that is the equations of motion. The second method here, what we can do also do is that you can use conservation of energy. Conservation of energy. Now, how do I use conservation of energy? First, what is the initial energy of the particle at this point? Initial energy at this point, it doesn't have kinetic energy. You just dropped it, right? So as a result of it, it doesn't have any kinetic energy. So initial kinetic energy is 0. Initial kinetic energy is 0. What is the potential energy of the particle at this point? mgh, because it's at this height, right? mgh should now be equal to final kinetic energy. What is final kinetic energy? Half mv square. Half mv square. Half mv square. Plus what is final potential energy? See, the particle started coming down like this. It has reached the ground, which means this value of h is equal to 0 here. This is 0 once again. So therefore, from here, what do I understand? I can get to know that half mv square is equal to mgh. And what do we have here? We have half mv square, right? In the previous expression, W equal to half mv square, work energy theorem, right? So therefore, now I can write work is done is equal to half mv square, which I can also substitute this equal to mgh. Okay, this is the third method. Okay, so thus by both the methods M1 and M2, first one is by kinematic method. I did not use any energies. The second one, I can either combine work energy theorem plus V square equal to U square plus 2AS. This I can use it to get the answer, or I can also use work energy theorem and conservation of energy to get the final result. Okay, see how nicely, okay, energy can be used, okay, to prove certain things. You can do it by both the methods. But while you do with energy, one advantage of doing with energy is that, okay, so it becomes easier for you. But only thing is, okay, you are dealing with scalars over here. But when you are looking at this, you're dealing with vectors over there. Okay, that you have to be careful. There is one more method also. Let us look at this fourth method, third method. This is M1, this is M2. In M2, I have used either of them to arrive at it. Okay, only two methods we have discussed. The third method is by vector method. Okay, I don't have space. Okay, let me write here. M3, I will write it here. Vector method. What does vector says? Vector tells you work done is equal to force vector dot S vector. That's what is a vector method. Now towards it. What is force vector? When you keep a particle here, what is the force acting on it? mg is acting downwards. Simple, right? mg is acting downwards. Okay. I did not look at component here. I just took only one force here. mg is acting downwards. Dot. Okay. I have a dot vector. And S, what is S here? Displacement. What is displacement? Displacement is I start from here, I reach here, which means I did not reach here. Along the y-axis, I have reached this displacement. So this should be h here. This should be h over here, right? Okay, see, it starts from here, it's reached over here. Okay, in projectile motion, you do it, right? You throw a particle, it goes all the way along and comes to one point. So you say that the y displacement is equal to 0 when you calculate the range. Similarly, when you consider here, it has come all the way along until here. Okay, mg dot h. Now there's a dot product, which means what? Which means what is the angle? So I will write this as mg into h into cos theta. Now tell me what is theta? Theta is the angle between mg and h, displacement vector and the mg vector. See, displacement vector is like this, right? mg vector is also like this. That means they're parallel vectors. When they're parallel vectors, what is the angle? 0, right? So therefore, I can substitute theta equal to 0, and thus I can get once again mgh. Okay, so this method I find it much more easy. Okay, you don't need to scratch your head. This is a bit difficult. You need to split everything and then get an answer. This one is very, very easy. Even a 9th standard student can do this one. So thus, there are 3 methods for this. Okay, friends, if you still like my video, then do subscribe to my channel. For most of the subjects, the entire video series will have a one problem, multiple solutions, so that you can get to know how to apply each and every one of these solutions to it. Thank you for watching my video until the end. Like, share, and subscribe to my channel for further updates. Thank you.